Hello everybody and welcome to Lesson 0. This is our first lecture video of the semester. So if you recall from my previous announcements, which if you haven't read those, I'd recommend you go over here, check them out on the announcements tab. Like I said before, this is my primary means of communication with you. So all the information, stuff you need to know is going to be coming through here, and any updates. If I have to change something or maybe something's not working, we'll do that over here. So anyways, this is our first lesson, our first lecture video of the semester. If you recall, we're going to do 2 videos per lesson. So we'll have a lecture video where I deliver examples and example code, just like I would as if we were in a lecture together, doing some live coding and demonstrating different concepts for you. We'll have that in a lecture video, and then we'll have our activity walkthrough video where I actually walk you through the activity that we would have been doing together in class. So in addition to being our first lecture video, this is also our Eclipse intro video. Eclipse is the IDE, the integrated development environment we're going to be using this semester to write our code. And I want to introduce it early so you don't have to go and log into Onyx to use kwrite anymore, because I know I already got a few complaints from students that it was just super slow because you are using that pop-up window over SSH, which is just slow. So I want to get you using Eclipse on your own computer as fast as possible. So Eclipse, to find it, look on your sidebar if you're on a Mac, look in your start window if you're on a Windows machine, and you should see this little moon-like icon. I clicked on it, and this is what it should look like when it opens. When you click on it for the first time and it's not open, a little splash screen will show up and it'll ask you to choose a workspace. A workspace is just a location where Eclipse stores all your project files. So at that point, if you want to put it somewhere else, maybe in your documents folder or something like that, you can choose to move your workspace. But I usually just keep it where Eclipse puts it by default. Sometimes take a little while to open, especially depending on how capable your computer is. On my little 2012 MacBook, it takes quite a while. So I already had it started up for you. The first thing you're going to see, and probably the most important thing for you to first notice when you open Eclipse, is the Package Explorer. Now, if I look over here and you see these little boxy looking icons, that is Eclipse's icon for a package. A package in Java is just a fancy name and a very Java-y name for a directory, so a place where we put files. And in more complex Java projects, we use different packages to organize our projects. So as you can see, I have my project folders over here. You can open them or close them using the drop down, and you can open and close the packages. In CS121, we're only ever going to have one package, and that package is actually invisible. It's just called the default package. So if you looked at this directory structure, actually on Linux, like on the command line where we ran our cd commands and we ran our little pwd to print our working directory, you would see that it's just your activity folder and then your files. There's not even this default package isn't even a directory that exists. It's just the default package just indicates to you that your files are just sitting right there in your project folder. So don't worry about the name. It's really just a fancy file explorer window. If you ever accidentally exit out of it and you're like, oh crap, where'd it go? If you go up here to the window on a Mac, I believe on maybe a Windows machine, it might be called, you might look for the View menu up here. But if you go to either Window or View, depending on what environment you're in, if you go to Perspective and go to Show View, not Perspective, Show View, and click Package Explorer, it'll bring that guy back up for you. So anyways, I've got a lot of stuff in here. If this is your first time taking the class, you won't have anything. And there's a couple different ways you can start a Java project, because to write an example or to start an activity, you need to have a Java project where you can write Java files. The first thing you could do is you can right-click here in this Package Explorer window and go to New Java Project. You can also go up here to File and go New Java Project. Never select Project, always select Java Project. Eclipse can be used for different programming languages, but it's specially made for Java, and we always want to write in Java Project. So always click that option here. So if you click Java Project, it'll ask you to give your project a name. So I'm going to call this Activity lesson01, and I'm putting that leading 0 in front of the 1 so that later on my activity folders show in the proper order, because we are going to get up to activity 23 is the last one. And so putting that leading 0 there ensures that it always goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. Keep this default location thing checked. That would allow you to open up a project in another location if something's maybe in your downloads folder and you want to open it. But we're always going to have that checked when we create a new one. Don't worry about these JRE things. This is if you were to have different Java runtimes in your installed on your computer, so maybe different versions of Java. It doesn't really matter. I have Java 8. And apparently I have Java E9, but I'm just going to use 8. I believe you guys are probably running 11 or maybe even 13. I think 13 is a thing, but it doesn't really matter. As long as it's 8 or older, you're good for your version. Now, this project layout thing, this is a really important option right here. So these guys you just leave checked normally, but this project layout is important because you probably, if you've never opened Eclipse before, have create separate folders for sources and class files checked. We want to go and say use project folder as a root for sources and class files, because this will keep our project structure more simple. If you click here, you're going to get this weird SRC folder that stands for source, as in source code. Later on, that directory starts messing with us and preventing us from doing what we want to do. So we want to just check this. Now, if you want to be sure that's always checked and you don't have to remember, click here on Configure Default, and you can actually select project or folders. So you're going to want to select project and then apply and close. And that'll ensure that every new project you create in the future is this. You won't even have to remember to create it. So I'm going to go here and click Finish, and we're good. So I always do one Java project per lesson or per activity. You'll definitely want one Java project per project. So basically for every standalone piece of code you work on, you're going to want a standalone Java project. So now I've got my activity 1, and if I expand that here, you see I don't have anything in it. All I have is this JRE system library. If you open this up, there's a lot of crap in there. That's because it's literally the Java language. So you don't need to worry about that. Eclipse just puts that there for you, so you can actually write Java code and run your project. If you deleted this bad boy, you find you have a hard time writing Java code. So now, how do you create a Java file? In kwrite, we just typed kwrite and then the name of the file we wanted, and it opened it, and we could start writing in it. In Eclipse, you right-click or go to File. As long as you have the proper activity selected over here, you're going to want to make sure you have the Java projects you want to use selected. Go to New, and then select Class. So if you remember from our previous program, we had, if I go to a different program, we had public class, and then this is strings and variables. It should be called Hello World. I guess I used this for a different example later on last semester. But notice the first line here says public class. That's because what we're really writing when we create a Java file is we're writing what we call a class file. And a class in Java, for now, all you need to know is that a class is just the most basic building block of a Java program. So, and each class is typically in one file. That's not always the case, but for our purposes, early on in CS121, that's how it'll be. So a class just represents a place, is just a fundamental entity in a Java program, and that's really all you need to know for now. Pretty much in a class is going to perform one function for you. So in this case, our class is going to just run some very basic Java commands to kind of demonstrate strings and variables. So for now, all our classes are really serving a purpose for is to just run some basic code. In the future, they can be used to represent entities like people or objects. But right now, our class is just a place with a main method. Really simple little place to run code. So now I'm going to give my class a name. This is actually going to be also the name of the file that Java creates. So remember, your file name in Java and your class name have to match. So whatever we put our name here is also going to be the name of our file. So remember, we need to use the title case. So I'm going to call this lesson 1 examples. just something really obvious and simple. Notice that I use title case, which is camel case. Remember, camel case is where each individual word has its own capital letter. In true camel case, this would have been a lowercase l because the first one starts lowercase, but when we put a capital, it's called title case. So just remember, Java class names and file names go in title case. We'll talk about what has camel case later. So I'm going to go ahead and click finish. And now notice that we've got our file created over here in our little default package. Has the name we gave it, already has .java at the end of it. And we've got our public class lesson1 examples up here. So again, this is the most fundamental entity in a Java project. We've got a class file. And notice we've got our first set of curly braces here. So like I said, in the future, we can have individual classes that represent things like people, animals, objects, whatever you need to represent in a program, and they can interact with each other. That's in more complex Java programs. All this class is going to do, this is going to be what we would call a driver class. It's the one class in the program that has the main method in it, which is the place where your Java program starts. This is also going to be the only class in our whole Java program. There's just going to be this one with the main method because we're just demonstrating the real simple building blocks that you need to know before you start writing more complex Java programs. So after we have our class, which is we need to say, hey, this is our Java class. Everything in here is Java code. Now we have our main method. And if you recall, this is okay if you have to look at your Hello World program or the slides to remember. There's a lot of words to type out here when you start your main method. It's public static void main string open bracket, close bracket, space, args, close parenthesis, open curly, boom. It's kind of complicated, and like I said, we're going to learn what different pieces of this mean throughout the semester. But all you need to know for now is that the main method, every Java program has one, and it's the starting point for your whole Java program. So your code starts running on this first line inside the main method and actually stops at the last line if there's nothing else to keep your program running. So now we're actually ready to start writing Java code and showing you what strings and variables are and going more in depth on some of those topics. So first off, strings. You've already dealt with strings already in your Java program. Remember when we did this? That was your whole activity 0 right there. But you already dealt with a string. Strings in Java are literally strings of characters. You know, in human life we deal, and especially regarding information, it's all strings, right? It's all things that we can write down, that we can record, that we can read later. Things that machines like computers can pass messages back and forth. Now, all of that data needs to be conveyed some way, and for humans, the way we like to communicate most of the time is through written words. And when you need to represent literal, just written text in a program, you use a string. And we signify that by using the quotation marks. Kind of like when you do the little air quotes when you're quoting something in a conversation. So this is called a string. It's literally a string of characters. In particular, when a string appears in a program surrounded by double quotes like that, and it's typed into the program, we call this a string literal. I like to remember that because it's literally a string. It's text in between two sets of quotation marks. And so we call that a string literal. And we'll show you different ways to represent strings in a little bit here. But when you hear the word string literal tossed around, just know that just means a string literally in quotation marks coded into your program. And we ran this statement here. It printed out hello world onto the string using system.out.println. So system.out.println is your first experience with a method in Java. Particularly, it's a method that's already part of Java. It's a block of code that does something. That's what a method is. We'll talk more about methods and we'll write our own later in the course. But a method is just a block of code that does something for you. And in Java, the println method is already built into the language. You don't have to write the code that prints out the words to the console yourself. That'd be some pretty complex code to actually print stuff to the screen and look at it. But Java has this println function built in for you. System.out represents the destination. that string is being printed to. The actual output of the system being your computer, and then out being the default output stream of that computer. So usually when the computer needs to output something, it shows it on the screen. Another example of something output could be a file. You could print stuff to a file instead of to the console. We want to see stuff printed to the console though, so we can read it. Now you dealt with print line. There's also another method. And just a handy tip, if you type sys out and then hit control space, it'll actually autocomplete that for you. You don't have to type it all out. I found that out way too late in my computer science career. There's print line, but there's also just system.out.print, and I'll do hi world here. And if you run this code, notice that we get hi world printed, and then hello world is on the line after it. However, if you add the ln to the end of that, we'll get those strings printed out on two different lines. So the difference between print and print ln or print line is that using print ln puts a hidden new line at the end of the string that gets printed out. And when we say new line in computer science, we mean literally a new line character. So it's invisible, you can't see it, but when you add a new line at the end of a string, it actually makes it so that the next thing that gets printed is on the next line down. So we like to say we print out hi world, new line, and then hello world. And that distinguishes strings that are on two different lines of text. We'll actually talk about other ways to put in new lines into your strings later on in this lesson. So that's the difference between print and print line. So next, I want to talk about a few more things we can do with strings. And also, something that, before I continue on, something that seems kind of obvious, but might not be so obvious, is that Java is sequential. So remember, I said our code starts out at the top of our main method and goes down. So hi world got printed before hello world. The code starts at the top of the main method, goes down, and it's over. When I hit that run button, you can see I get that little red guy down here, flashes red for 1 second, showing that my program's running, and then it's over. Our main method ran the 2 lines of code, and then exited. Our program ended for us. So anyways, now we can start messing around with strings a little bit more. So something you can do that we do all the time with strings in Java is we concatenate them. When I say we concatenate a string, we can literally take 2 strings if I could spell, and concatenate them together. Concatenating is just a fancy word for smushing 2 strings together. So notice, this plus here didn't get printed out. Instead, we got our 2 strings merged together. So usually we think of the plus sign, or the addition operator, in the context of adding numbers together. But when we use it in between 2 strings, it's not the addition operator, it's the concatenation operator. So it takes our 2 strings, running it from right to left, takes hi world, and then smushes hello world again on the end. If you wanted this to look like a sentence, maybe you'd capitalize that H, but you'd also probably want a space. So I can add a space here at the end of hi world and run it. And now that looks like a nicely formatted sentence. Or, if I really wanted to, I could even concatenate a space into these 2 words. And notice, it looks like there's nothing here, but there's a space. There's an open quote, end quote, and that is a valid string. This, believe it or not, is also a valid string. It's actually a string we use all the time. So just double quote, double quote. That's called the empty string. So notice, it's like we didn't even have it there at all. It's literally just an empty string. But we use that actually quite often to, if we're constructing, maybe we're building a string. We don't know what our program's going to output until the end, so we start out with an empty string and add stuff onto it by concatenation. That's something we actually do quite often. But I'm going to put that space back in there and run it. And again, notice that our program starts at the top and runs down, but it also follows your traditional order of operations for math or for just reading a line of text. We start on the left and we go to the right. So that's concatenating two strings. It's really handy because say you have to print something out really long, and say we just have a bunch of crap in here, and it gets past this little line that Eclipse shows you. This little line tells you, hey, you should probably think about starting a new line in your program, because I could just keep typing and Java wouldn't care. But that's the kind of the typical width of most terminals. And so if you go past that, your output's going to be really hard for a user to read. So typically we like to just start a new line. So if you're printing something out really long, you can actually use concatenation to split the lines. And I actually like to indent after I do that to kind of show that this guy is paired with this line. But now, notice, we get all that crap printed out. And we were able to have our print line statement over two lines. And that plus operator right there is really important. If we were to remove that, we would no longer have a valid string because Java wouldn't know what to do at the end of this line. But putting that concatenation operator there tells Java to continue that statement on to the next line. Another fun thing we can do with concatenation is we can actually concatenate numbers onto strings. So I can do this, and what will we do? We'll do 55. And when we concatenate this number onto this string, Java treats that number just like a string and plops it on at the end there. So notice that this 55 isn't in double quotes. We could just as easily put it in double quotes and run it, and it wouldn't change our output at all. This 55 here is actually a number literal, so it's different than a string literal. In Java, numbers don't have to be in double quotes. Especially if you want to do math on the numbers, you shouldn't put them in double quotes because then they'll be a string and Java won't treat them like a number. Java is what's called a strongly typed language. We'll talk about more of that when we talk about variables. But numbers in Java are actually treated differently than strings, and like I said, we'll see more about that in a minute. But I can concatenate numbers onto my strings, and they'll show up. Now, I can also concatenate more numbers. Now, you might think, hey, is this going to concatenate? I'm not very good at math, so let's do math that I can add up. Is this going to concatenate 9? Sorry, that's hard to say. Is this going to put hi world 9 or hi world 54? Well, let's find out. So, you might have thought that Java would add that 5 and 4 together and add it on to the end of our hi world string, but it didn't. What Java does is, like I said, it runs the code from right to left. So your concatenation operators have the same precedence that your addition operators would have if you were doing normal left to right arithmetic. And so Java runs your code from left to right. It takes your hi world string and then it concatenates 5 onto the end of that. So after this part of the state expression runs, we've got hi world 5, and that's our string. So we get a string concatenated with a number, and we still get a string. So string plus number equals string, essentially, if you want to summarize it down to that. Now, if you wanted this to be 9 and not 54 on the end of your string, there is something you can do. You can use parentheses. Now, usually you're used to parentheses being used in a mathematical expression to group your operations together. And we use that all the time in Java. But we can also use parentheses to group our concatenations together. So now, just like in your math class, Java will run what's in the parentheses first. Even though hi world appears further to the left in our expression, 5 plus 4 is inside the parentheses, so it has higher precedence. So the 5 and 4 are going to get added together. That's going to be 9, and that's going to get added on to the end of hi world. Pretty cool. So we can do all kinds of cool stuff like that. Now, what if we wanted to have one print statement, but we wanted a new line in there somewhere. Let's do our hi world, hello again, world. Now let's put a winky face there just for fun. Now it's kind of sassy, hello again world. But anyways, if we wanted this hello again world to be on a different line, but we still wanted it inside of our print line statement, there is a way to do that. I talked about the difference between print and print line, and that there's another way to put new lines in your code. That way is through escape sequences. If I were to put \n in here, you might think that \n is what's going to get printed out. But notice where the \n is, we actually get a new line. Now, the reason for that is that \n has special meaning in Java strings. It's what's called an escape sequence. Now, escape sequences are so called because back in the day, they were actually used to tell the computer to do something different other than printing a character to the screen. So notice that our new line, we can't see it. It's invisible, right? If we were controlling a physical printer, the printer would actually have to move down to the next line. And if we're printing code out into an actual monitor, particularly on older computers like an old school CRT monitor, it would actually have to move the output down to the next line. That's why they're called escape sequences, is because back in the olden days, you actually used to have to hit the escape key and type a special code in to get something like a new line or a tab. Now we're lucky we get to use the \. So the \/ actually has special meaning in Java. If we put \/ by itself, you're not going to get a \/ printed out. In fact, it's going to give you an error. Now let's actually see what it says. Invalid escape sequence. So you have to have your \/ and then whatever you want. And so let's say we wanted to put double quotes around our hello again world. We wanted to do like air quotes. We can, if we do this, notice our string gets really messed up. To have a valid string in Java, you have to have one set of double quotes and then the other set. So begin string, end string. So now we've got double quote, no concatenation. So this isn't even inside of a string. Notice it's black, it's not blue. And then begin string again. So Java has no idea what we're typing here. It's like, hey, this isn't a string, and it's also not a number. It's just garbage. Java can't, there's hello again world outside of quotation marks has no meaning to Java. And so we need it to be inside a string. So if we want to use those double quotes there and actually have that show up in our string, we actually have to use an escape sequence. So \/ double quote will work just fine. And notice again here, we've got a string and then something and then another string. Kind of weird, right? So we need to always put the \/ in front of our double quotes if we want them to show up. So now, again, we've got a valid string. We have start quote, escape sequence, some string characters, escape sequence for a double quote, some more string, that, and then finally the end of our string. And so now if I run this, it works just fine, and we see our double quotes in there. What about if you want a \? That escape sequence is kind of funny. It's just \/ will get you a \/ showing up in your string. And that's the basics for strings. We went over the escape sequences, concatenation, print versus print line, how a string starts and ends. Remember, you got to have that open double quote and then close double quote for it to be a valid string. If I was printing this out and I forgot my double quote to print out hi world, notice Java gets mad at me. String literal is not properly closed by a double quote. We need that double quote in there. So we just finished talking about how we can print out strings, how we can combine them and manipulate them using concatenation. Now we want to talk about how we can create a string and store it and then use it or manipulate it later. Now, all programs deal with data in some way, and usually we have quite a bit of data, and we need a way to store it and save it, give it a name, and use it later. and that comes in the form of variables. Now you might be familiar, or hopefully you're familiar, because algebra is definitely a prerequisite for this class, with the concept of variables from your math classes, where we give a value a name that we can address it by and use later. Variables in a Java program work the same way, except for instead of representing a piece of data in your head when you're doing calculations on paper, it actually is a reference to a physical piece of memory in a computer, where the computer will store a value, and then when you use that variable, it'll go get that value later. You could think of it kind of like an address. And so the way we declare variables in Java is we have to give our variable a type and a name. A lot of programming languages, you can just declare a variable by giving it a name. Java is a strongly typed programming language, which means when we create a variable, we have to tell Java what kind of data we're going to put into it. So that can be strings, that can be numbers. Today we're just going to deal with strings. So if I want to create a string variable, I need to give it a type first. That's string. I need to give it a name. I'm going to call my string quote. And now we need to give it a value. And just like in your algebra class, we're going to use the equal sign to say equal something, but this isn't saying that quote is equal to what we're about to type. Let's just say hello CS121. It's not saying it's is equal to this. This is actually what we call the assignment operator in Java. And we're saying our variable quote is going to reference this string. So whenever we use quote, you can substitute the value of quote, in this case hello CS121, in. So now we can print out quote and hello CS121 will get printed. So now we can use this variable to reference the string that we created anywhere we want. A really good breakdown of variables is here, where we've got color-coded the type, the name, the assignment operator, and the value. Notice the assignment operator always goes type, name, assignment operator, value. So the thing getting assigned into the variable always goes on the right-hand side of the equal sign. And so we've got our first variable assigned. Now in Java, you can also do this. You can just have your variable, and I'm going to put a comment in here. So imagine right there where it says do some stuff, our program is doing some things, and we can assign quote a value later. In this case, notice the same stuff gets outputted, but we were able to declare the variable quote. This is called variable declaration, where we said, hey Java, I want you to reserve a slot of memory the size of a string to hold quote. Now in Java, all variables have a certain size. Strings get quite a big allocation of memory. We'll talk about that later. Strings are actually a special type of variable in Java. But we're like, hey Java, we're going to have a string. We're going to call it quote, and just know that's going to exist. We're not giving it a value yet. Then we do some stuff. So imagine, maybe make some calculations or whatever. And then we give quote a value where we say, hey, quote equals hello CS121. And now quote is going to reference that string wherever it's used. Now, I made a comment up here. That looks kind of weird. I don't think we've talked about it yet. But a comment in Java is text that's literally a comment on the code, like it describes what the code is doing, or maybe is a placeholder like we've used here, where we're saying, just imagine, for example, the code does some stuff here. And a lot of times we use comments to inform another programmer or someone who's reading our code what the code is doing right there. So if it's doing something important, or maybe the function of that code is not quite so obvious, we can leave a comment. Now, notice do some stuff was never printed out. comments don't actually get compiled by Java. They're actually ignored by the compiler. So they only exist in our source code for us humans to read. So whenever we put // and type stuff on one line, that's a comment in Java. Now, I can't do this and keep typing down here. Notice Java gets angry. If I want to have a multi-line comment, I do /*, and we can get a multi-line comment, and we can type multiple lines. Whatever's between this /* and this /*/ becomes a comment. So we'll use those more in the future, but I use them in my example sometimes because I'm like, hey, you know, just imagine some stuff happens here in your program to show that you can declare a variable and then use it later. Now, something that's important in Java is variable names. First of all, if I wanted this variable to kind of be two things, maybe I want to call it quote me. I need to use camel case. So camel case again. Oh, and notice Java telling me is now we don't have a variable in our program named quote. Quote cannot be resolved to a variable. So we got to make sure we change this to quote me. So again, we have to reference our variable by name. Notice that quote me is 2 words, and in our variable name, it's all one word. It starts with a lowercase letter. That's camel case. The first letter starts with a lowercase, as opposed to title case, where it's camel case but with a capital letter at the beginning. We've got our lowercase letter here, then the capital M-me for the second part of the word. Now, if we did this, notice that quote me with no camel case will work, but how can you tell that that's 2 words? It's kind of hard to read. So this is camel case in Java is what we would call a convention, where it's not required. Java will still run your code without it, but if you were to do it and then go to work somewhere, people would probably have a talk with you about following proper conventions, where variable names that are 2 words, we use camel case. Now, we also want names that are good representatives of what the variable does. So maybe quote me is not even the best. Maybe hello would be more appropriate, or hello message, potentially. So I'm going to change that to hello message so that my variable name is meaningful. This is something I'll even leave feedback on your projects about, is say, hey, use better variable names. You know, like naming this string X. That has no meaning in the program. And sure, it's fine if we were to do that for a small example program like this. But if the program gets more complicated, like what does X mean? You know, we want to make sure that we're giving our pieces of data appropriate names so that we can use them later on and know what they mean. So we want to make sure we're using good variable names. I also can't have duplicate variables. So if I wanted to use hello message on down here, I can't do this. Notice even though this is correct Java syntax, Java's getting mad at me. It says duplicate local variable. So a local variable is just basically just a variable in your program, specifically variables that are at the same level of indentation. So we'll talk about that more later, but just know a local variable is just another name for a variable in your program. So Eclipse is telling me, hey, you have a duplicate variable. We can't declare another variable named hello message. So you can only have one declared variable with a given name. However, we can reassign hello message and then print it out again later. So here I would say we mutated hello message. We changed it, gave it a new value, and printed it out. So notice we can reassign variables later on in our program. So hello message now equals hi, and they both get printed out. Now, one more thing that you can use in your programs is constants. So let's say I wanted to get real fancy and print out a border around my hello message. So let's say I wanted to do something kind of cool and maybe put a few dashes around our hello message so it looks like this. Kind of fancy, right? Now, copy and paste work just fine, but we like to be more efficient than that. Programmers are notoriously lazy. We don't like to type the same thing more times than we have to do. That's one reason we use variables. So another type of variable you can have in your program is a constant. Now, a constant you can't change. And I'll show you that in a second. But first, let's create our constant and use it instead of these double quotes. So notice, we had to type 2 lines, but we already have a much easier to type thing. We don't have to remember how many dashes we put. We don't have to count them. We can just use our constant name. Now, forgot something up here. Forgot my semicolon. Guarantee you're going to be doing that in one of your first programs. So now we run this, and we got our border, right? Because our variable value gets substituted in our print line, just like with our hello message. Now, let's say we wanted to change this on the fly before we printed out our second border. Maybe we want it to be equal signs instead, right? Notice Java's going to get upset with me. It's going to say, hey, the final local variable border cannot be assigned. It must be blank and not using compound assignment. So that's a fancy error message. Really all it's saying is that, hey, border is a constant. When we put final in front of the type, think of that as saying this is the final value this variable is going to have. It's going to be constant. And Java will not allow you to change it after you give it its value. And so that's nice because border now has special meaning in our program. It's just these dashes and nothing else. And Java won't let us reassign it. Now, why did I use all caps? It's, again, convention in Java to use all caps. So I could just say this, and it wouldn't be giving me errors down here if I didn't change that, if I changed that to lowercase. But it's convention in Java to use all caps for your constants. Personally, I think it's a convention because imagine our code extended far beyond these lines, out to where we couldn't see it, maybe out of view of this declaration of our constant. We'd have no way to know if just lowercase border was constant, so you might try to reassign it and get an error. By using all caps, we show that, hey, this is a constant, its value's not going to change. So with that, I think you have all the tools you need to work on your modern art assignment. I'm going to get working on the walkthrough video. I hope this was helpful. Thanks, everybody.